Hi everyone, in this video we're going to look at the leveling calculation using the high-tech collimation or high-tech instrument method. In this example, we're going to look at the leveling run. You are going to start at benchmark number 1 and you will need to determine the elevations or reduced levels of a series of points. Include point A, point B, point C, point D, and then connect to benchmark number 2 to check the results of the leveling run. So you will need 3 setups: setup number 1, setup number 2, and setup number 3 due to the long distance from benchmark 1 to benchmark 2. You will need the change point to connect 3 setups together. So we have point B and point D are 2 change points to connect the leveling run from benchmark 1 to benchmark 2. So let's go to the details in the next slide. The booking and reduction process is how you can write the readings and calculate the reduced levels of the points that you are measuring. So the procedure is that you will start from the first point to the last point. So you will use one row in your leveling sheet to calculate and write the reading of that point. So we start with benchmark number 1, that is your first point, and the direction of the leveling run. And the reading of benchmark number 1 you write in the first line over here. And when you take the next reading for the next point, you write in the second row. That is for point A, and the reading is 1.432. The next point in this leveling run is point B. That is the third point, and the reading, you have the foresight reading, 1.716. That's the last reading before you move your instrument to the next setup. And you keep the stuff here at point B as the change point. You make a new setup over here, and then you take the backside reading to point B again. So that's why you will have 2 readings at the change point. The change point is the point where you will have all of the backside and foresight reading. So you have both foresight reading from the previous setup, and you have the backside reading from the next setup. So this is point number 1, 2, 3. And with setup number 2, you start with backside reading to point B, and then you move the stuff to point C to carry on the survey. So that's the point number 4. And the reading for C is 2.272. The next point is point D, number 5. You have the foresight for point D. Then you keep the stuff at point D, you move your instrument to a new setup, and you take the backside reading again at point D. So you have both backside and foresight readings at a change point. And the last point is the benchmark number 2. where you have the 4 sides reading only. So the first reading after a setup is a backside. The last reading for that setup is a foresight. Any reading which is not a foresight or backside is the intermediate side, where you only have one reading at that point. So that is the difference between the intermediate side reading and the change point, where you have both foresight and backside reading. Again, an intermediate side reading is the only reading you have for that point, and it's not the benchmark as well. It's not the first reading of your leveling run at the benchmark. It's not the last reading of your leveling run. It's the points in the middle of the leveling run, where you only take one reading only. So that's why at point A, you need to write the readings into the intermediate side column. Similarly, point C, only one reading at point C. That is the intermediate side. So you write to intermediate side column. This is the example where we have done the booking and calculation. So you will need to do the first step to write all of the readings into the 3 columns: backside, intermediate side, and foresight. So then you're going to do the calculation using the height of collimation method. And the results will be the reduced level of every point in the leveling run. Include the correction and check for any errors if occur. So now we are going to move on to the next steps to explain about the calculations. Firstly, we need to know the principles of booking, as we have seen the table before. Each of the reading will be a backside or a foresight or an intermediate side. So here you need to remember the definition. Backside is the first reading of a setup. The last reading of that setup is the foresight. And other reading is not a foresight or a backside, will be the intermediate side. And normally that is the only reading at the point that you're measuring. And it's not a benchmark. It's not the first reading of that leveling run. It's not the last reading of that leveling run. It's the points in between where you only take one reading. So it's different from point B or point D. In this case, you have both backside and foresight reading. So A and C are intermediate side in this leveling run. And write down the reading for each point in one row in the leveling sheet. And you have to follow the order from the first point to the last point. Now, look at the procedures to calculate the reduced level of the points which is unknown using the height of instrument method. Step number 1. Height of instrument or collimation line. We start with setup number 1. So you know benchmark number 1, but you haven't known point A and point B reduced level. Step number 1, calculate height of instrument for that setup. So that's going to be this level. using the known point, and you add the backside reading from the benchmark. So known point, and then add the backside reading, 1.717. Known point, and you add the backside reading. You get the height of collimation for that setup. So now it's 30.947. Step number 2. Reduce level of the next point equals height of instrument minus the reading at that point. So now we need to calculate for point A, and you haven't known the reduced level here. So use the height of collimation minus the reading at that point. So that gives you the results. Height of instrument minus the reading 29.515. 29.515. Point B, height of collimation minus the reading at that point. $29.231. $29.231. So now we've finished the first setup. From benchmark 1, you calculate reduced level of point A and point B. So now we move to the next setup. So you have a new height of collimation or height of instrument. So you're going to repeat step number 1 and step number 2 for the next setup. So again, you are going to calculate height of instrument for setup number 2. So this level. And the height of instrument here equals reduced level of point B. And you add the backside reading at point B. So now it's this value. So in the same line over here at point B, so you calculate the height of collimation. So use the reduced level of point B, and we add the backside reading at point B. So you get the height of instrument at point B, 32.149. And then calculate reduced level of point C and D in this setup. With point C, reduced level equals height of instrument minus the reading at that point. Height of instrument minus reading at point C. Give you elevations over here, 29.877. For point D, in the same setup over here, height of collimation minus the reading. So that gives you 31.196. So then you've finished setup number 2, and you have to move to the next setup using the same method here to calculate the elevation of the benchmark number 2. Even you know that, but you need to check. So that's why you have to calculate the reduced level of the benchmark number 2 as well. So for the last setup here, you need to calculate the new height of instrument. So this is the level for that setup. You use the elevation of the known point here at point D, at that change point. You add the backside reading. So you get the height of collimation HI. So you calculate and put that values over here. So that's why I mentioned repeat step number 1 and 2 for setup 3. And then for benchmark number 2, use the height of instrument here minus the reading at the last point as the benchmark 2. And that's going to give you the height of the elevation of benchmark number 2. So then you can compare to the elevation that you have known before. So we now finished the steps to calculate the reduced level of different points using the height of collimation method. Step 4. Calculation check. Once you finish the calculation of the reduced levels for every point of your leveling run, you need to make sure that you have no errors in writing or calculating the collimation line level or the reduced level of those points. That's a very simple check. The steps is take the sum of the backside minus the sum of the foresight and compare to the last reduced level and the first reduced level of the last point and the first point. In this case, the sum of the backside plus. So that gives you 5.451 meter. The sum of the foresight plus that gives you 5.674 meter. So use the formula over here. The sum of the backsides minus the sum of the foresides, that gives you minus 0.223 meter. And you compare to the reduced level of the last point, which is 29.007 minus reduced level of the first point. So here we have the same results. So it means you do the writing and calculation correctly. The next step is calculation of misclose. So we've known that there are 3 sources of errors. Even if you have no errors in the measurement, the errors may come from the instrument or from the natural errors like the wind or temperature. So that's why we need to check the misclose. That is the reduced level of the known point and the reduced level that you have calculated. We will then compare that misclose with the allowable misclose, the maximum misclose we can have in the measurement, by using the formulas given in the standard, or before you do the job, there will be the specification of the allowable misclose. This is the example of the misclose of the leveling run that we are doing. Firstly, we check the misclose by compare the reduced level of the calculation and the reduced level that you have known. In this case, the calculation gives you the reduced level of the benchmark 2 of 29.007 and its known value is 29.001. So the difference here is 6 millimeter. So due to the natural error, instrumental error, personal error, we don't know where we make the mistakes or where the errors occur, which sources specifically, but finally you will have 6 mil difference between your observed reduced level and the known value. So it's acceptable if this misclose is small or smaller than the allowable error or allowable misclose. So that's why using the formula to calculate the allowable misclose, we can use the number of setups to calculate the maximum misclose. We have 3 setups. In this case, using the formula 5 millimeters times the square root of number of setups. So the number of setups, if you don't have the diagram here, you can calculate from the number of backside reading or number of foresight reading. How many backside readings you have, that is the number of the setups. 1, 2, 3, or number of foresight 1, 2, 3. So you have 3 setups, so that's why the maximum errors you may have is 0.005 times 3 times square root of 3 in meter. You convert to millimeter, you're going to get maximum 9 mil for the error. So here it's acceptable because you only have 6 mil in the error at the last point, benchmark number 2. So if the misclose is larger than the allowable error, so then the results are not accepted and the level run will need to be repeated. Distribution of the misclose. Once the misclose has been found, it is necessary to distribute this misclose evenly throughout the level run. We assume that an equal amount of error has been made after each setup, and therefore the adjustment per setup equals the misclose divided by the number of setups. We are going to see an example in the next slide. The last step you need to do is to distribute the misclose for all of the points in the leveling run. So we have known that there's a misclose of 6 mil from the known point and the elevation that you calculated. So we need to bring the reduced level of the benchmark number 2 to the known value. So in this case, we need to minus 6 mil from the calculated value to bring it to the true value over here. And for the first point of the benchmark here, so we don't need to make any correction to that because we keep the known elevations here and we do the calculation for the rest of the points. So here you're going to have 0 millimeter and 6 millimeters minus 6 millimeters here to bring this value to the known value. So you know that from the first point you have 0 correction and the last point you have minus 6 mil correction. So for the other points here in between, so we are going to do the correction for each setup separately. The first setup adjustments will be misclose divided by number of setups. So here we have 3 setups: setup number 1, setup number 2, and setup number 3. You can calculate how many backsides. That is the number of setups: 1, 2, 3 backsides, or 1, 2, 3, 4 sides. So you have 3 setups. Adjustment for the first setup, misclose divided by number of setups, you have 2 millimeters. So but the sign is negative. So the sign is negative over here, and it's the same for all of the other setups. Minus 2 mil, minus 2 mil. So then you can bring the reduced level here to the adjusted value. So here you have the same value for the benchmark number 1, 0.230, and the next point, point A, due to some error, and now you adjust the elevation to account for those error. 5, 1, minus 2, 3. This point, 29.229. So this is setup number 1. Setup number 2. So we keep the same correction as the first setup and you add another 2 mil to that. So we then have to subtract 2 and 2, subtract 4 mil for the second setup. So for every next setup, you add the same adjustment as the first setup. So in this case, for the points of setup number 2, point B, C, D. Point B we already adjusted from the previous step, so we don't need to change it again. We do for point C and point D. So you minus 4 over here, 29.873, and that point 31.192. The last point over here, so that is the setup number 3. So if you check again from setup number 2 minus 4, and if you add another 2 mil from the first setup over here, you will have minus 6. So that is exactly the misclose value, and you can bring the benchmark number 2 here to the known value. So that's how we do the correction after you know the misclose and you check the allowable misclose. So then bring all of the reduced levels over here to the adjusted reduced level by doing the correction. So congratulations, we have now finished the booking and reduction process for a leveling run. So basically the process is going to be booking. It means you write all of the readings from the leveling run into the booking sheet. Write down the backside, inside, and foresight reading for each point. So then you calculate the reduced level of all of these points using the high-turf collimation or high-turf instrument method. We then check for the misclose and make the correction to make sure that all of the benchmarks here have the same elevation after adjustment compared to its known value.